Unit 3, Lesson 1. Today we're going to talk about a relationship that's known as periodic. Periodic. What this means is it repeats perfectly, and you can predict how it's going to repeat, okay? So we're going to be talking about periodic relationships. For example, a clock. The small hand on the clock is periodic because you can guarantee, as long as the clock has batteries, that small hand on the clock, which I don't have one in here, will repeat itself every how long? Every 12 hours, it goes all the way around the clock. Every 12 hours. Now, the bigger hand, the minute hand, it is periodic, but it's not on a 12-hour period. How long does it take for that big hand to go all the way around?
60 minutes.
60 minutes, 1 hour, yeah. So those are periodic functions, something that you know is going to repeat, and you can predict how often it's going to repeat. Does that make sense? Okay, so that's what we're going to talk about today, periodic relationships. And so here's the definition of it. Look over here. This is heavy math. Again, you can read this on your own up here, but I want to explain. Oh, wait, sorry about that. Look down here. I'm going to try to explain some of these words using these math symbols here. Now, I want to remind you, because it's been a Christmas break, that F represents the Y variable. What does F represent? The Y variable. So then, obviously, X represents the X variable. Now this, what's on the inside deals with X. What's on the outside deals with Y. Okay, I want you to look on both sides of the equation. What can you tell me on the outside of the parentheses? So don't look inside. Ignore the inside of the parentheses. Look outside the parentheses. What do you see on the left side that's outside the parentheses? F. Okay, what do you see on the outside of this parentheses? F. Notice they're exactly the same. What's on the outside of the parentheses on both of these? F. Now F represents the Y. What it's saying is it's going to have the same Y value. But now look on the inside. Do the insides match up? No. So what makes something periodic is if the Y's repeat, same Y's, but with different X's. Notice here's an X, here's an X, but this X has something added to it. And that's what I'm going to explain to you today. What is this NK? Well, N is going to be an integer. That means like a number 1, 2, 3, 4, 5, or -1, -2, -3. N is one of those type numbers. K can be anything. Okay, K, well, usually it's going to involve a pi in our class. Usually it's going to be like pi over 2 or just pi by itself. Okay, so that is what makes something periodic, is that which, and like you tell me, which variable repeats? The Y's repeat when X's are different values. Okay, so specifically the functions we're going to deal with in my class more often than anything are sine, cosine, and tangent. That's what we're going to use these for. There's also 3 others that we're going to routinely see, but we're going to call sine, cosine, tangent. Okay, so first off, let's go over some vocabulary. Periodic, I've been telling you that. Periodic means what?
Repeats.
Repeats what? The Y values, repeats Y's at regular. Regular means you can guess, you can predict on how far the X interval is. So, for example, this is periodic. How do I know it's periodic? Tell me about my Y values here. You see how that's the same height? What about this one? Is it the same height? Now, here's what you would do. The period would be how far apart they are. So how many units apart are these two spots? Well, this one is about how much? Negative, what number would you guess? Negative 4.8 or so. Okay, what unit is this at approximately? 1.5, maybe 1.6, somewhere in there. Okay, you could predict that the difference between those two, how many units apart is it from negative 4.8 to 1.5? Anybody know that one? It's approximately 6.3 units. Now this one we'd actually find out, I would be pretty sure it's actually 6.28. You know where 6.28 comes from? Anybody in here got their thinking cap on already? 6.28 is what I'm guessing the actual number would be. 2 times pi, very good. This period would be 2 times pi. Remember how I told you a second ago? You're going to have a whole number or an integer that can be positive or negative times another value, which is usually pi. This one would be 2 times pi. This repeats 2 times pi. Now check it out. We're saying this Y value repeats itself, right? Now check this out. Does the minimum also repeat itself at the same distance apart? Yes, it does. So that's what's periodic. That means periodic, okay? Let's go to the next one. I'm going too slow here. A cycle. One cycle is going from like maximum to maximum or minimum to minimum. That's what you'd call one cycle. It's not just, hey, I hit the same value. Like this would not be a whole cycle. Let me make sure I'm making myself clear. Everybody looking at my picture? Blue to blue. Is that one cycle of the whole period? From this blue to this blue?
No.
No. You wouldn't look at middle values. That'll throw you off. You always either look maximum to maximum. This would be one cycle. One cycle from maximum to maximum or from minimum to minimum. That's where you get a cycle from, okay? Amplitude is the height to the depth of the wave divided by 2. So this is 2 times the amplitude right there. That's 2 times the amplitude. The amplitude is actually half the height, if you will. And finally, midline. What do you think midline means? Yeah, wherever the middle is, that's considered the midline, which in this case, it would be y equals 0. Why? Because that's the axis you cross through. We cross through the y-axis and we cross through at 0. That would be the midline. Okay, so there's some vocabulary for you. Make sure I got it all. Yep, that's all the words there. All right, and now let's look at some examples. For each, determine whether the function is periodic or not. If periodic, label a cycle and determine the period and the amplitude. Okay, so the first one, what do you think? Does this look periodic to you? Does it look repetitive? I agree, it's periodic. Let's put periodic here. This one's periodic. What does periodic mean again?
The Y's repeating.
The Y's are repeating on regular X intervals. Okay, so now, let's label one cycle. What's the easiest way to identify a cycle, have I said? Maximum to maximum. Let's go here to here, and we'll call this one cycle. And determine the period and amplitude. Okay, so define the period and amplitude. Period means how many units did it take, how many X units did it take to go from this spot to this spot. Okay, what is this almost?
-3.
It's almost -3. So what do you think it actually is then?
-0.8.
Let's just say it's about negative, well, I was going to say 2.9 or so. Let's just say it's approximately negative 2.9. That's an approximate. We're just guessing. Okay, what X value do you think this is? 1. So approximately how many units is the period? About 3.9. I'd agree with that. It's approximately 3.9. All right, Eileen, we also have to find the amplitude. Do you remember where to label the amplitude, where that came from on the picture? Take a guess. What did amplitude have to do with? If period went left and right, from this left value to the right value, what do you think amplitude goes? Up to down. So how high is it? Yeah, it's up 2 units. How low is it? -2. So it goes up as high as 2. It goes down as low as -2. How many units apart are those? How many units apart is that? 4. And so the amplitude is actually, is the amplitude 4? The amplitude is 2. Remember, that is 2 times the amplitude. That right there is 2 times the amplitude. A cycle is the period. I need to go ahead and write that in the note. One cycle is equal to 1 period. A period is just the distance. So 1 full cycle is equal to 1 period. And the maximum to the minimum, the distance there is 2 times the amplitude. So in this case, since 2 times the amplitude is 4, since they're 4 units apart, since 2 times the amplitude is 4, the actual amplitude itself is 2. Does that make sense? All right, let's try the next one. See if you can walk me through it. Let's see, what do you think? Periodic or not periodic?
No.
Christopher, you're very good. Why do you say it's not?
Straight lines.
Well, it's not necessarily because it has straight lines. There's a different reason it's not periodic. Ready for this? Okay, what I'm going to do is I'm going to model this slope. See how the blue line has the same slope here? Okay, does it have the same slope there? Same slope here? Okay, same slope here?
No.
See how the slope's different?
Yeah.
So that would be a reason it's not periodic. Let me put another one on there for the sake of the notes. So you can see that. Just go ahead and put on here, not periodic. This is not periodic. Because the y values are not repeating themselves, that y value is not going to be in line. All right, let's go on. Let you flip the page over. Okay. What do you think on C? Periodic, not periodic? Very good. I'm hearing not. Now, why is it not, Kathy? What about them? Okay, actually, in this one, I think the slopes are the same, but you're correct when you say it's not periodic, but it's a different reason. I think these slopes are the same. I think. Those look the same, but there's a different reason this is not periodic.
It's going up.
Remember the definition of periodic? What is the definition of periodic? The y's have to repeat. Now, here I'm checking the slope's not the same. The slope is the same, which would make you think you have repeating y values. But let's just say this maximum right here. What's the y value on this maximum? What's the y value? -1. What about the y value on this maximum? 0. What about the y value on this maximum? Are the y values repeating? No. So this is not periodic. And maybe we should give more explanations since I didn't do it before. Since y values are not repeating. On each maximum. There we go. And each maximum. Okay. So that's why this one's not periodic. Yeah. Again, whoa. Was not expecting that to happen. Let's take that. Let's make that not happen again. Okay. What makes something periodic is the y values have to be repeating on regular x intervals. That regular means the same distance apart. Okay. And now finally, let's look at D. What do you think about on D, Augustine? I'll let you take your guess on this one.
Periodic.
I agree. This one is periodic. Now, if it's periodic, we should be able to label one cycle. What do you look for a cycle? Maximum to maximum. That would be one cycle. And one cycle is the same thing as a period. One cycle is going to equal, I'm going to switch colors here, one period. And the reason I'm going to do it switching colors is in green, I'm going to say what the period actually equals. So you wouldn't just say, hey, it's true that is a period, but how many units apart is it? This one I don't have to approximate. It looks like we can tell easily. How many units apart are these? 4. Is it 4 divided by 2 or just 4? Just 4. Okay. It's amplitude that gets cut in half. How do you find an amplitude? The height from the maximum to the minimum. This is going to be 2 times 1 amplitude. That is 2 times the amplitude right there. So how many units apart is it from -1 to +2? Okay, so 2 amplitudes would equal 3 units. So what does that mean 1 amplitude equals? I'm not spelling that right. Amplitude. There we go. Amplitude. Okay. It would be 3 divided by 2, which is, y'all said 1.5? I agree with that. That would be the amplitude. Okay, so that's periodic functions. That's the vocabulary for amplitude, for periods. What we did not do on this is the midline. We could have done the midline. Where's the midline on this one? Where's the very middle? Well, let me ask you, is this the very middle of the graph? No, tell me when you think I hit the middle.
There.
Yeah, that's the midline right there. So if you're ever asked about the midline, that's what that is, and it's always on a periodic function going to be the line y equals something. It's where it crosses the y-axis. Where do you say this crosses the y-axis? 0.5, 0.5. There you go. That would be the midline. So if they ask you about that, that's how you find the midline. Okay? With that, I think we have our first. Oh no, I have two more. Let's call it out quickly. What do you think? Periodic, not periodic? Periodic? I think it's periodic. It looks good to me. Okay, if it's periodic, we ought to be able to label one cycle. How do you label a cycle?
Maximum to maximum.
Maximum, maximum. Now, do you have to choose maximum to maximum? You could do any point as long as it's the repeating point. I think it's easiest, though, to always label maximum to maximum. One cycle, and one cycle happens to be equal to one period as well. How many units apart are these? 4. So the period, again, is 4. Period is 4. How do we find the amplitude?
Maximum to minimum.
Here, maximum to minimum. Not technically maximum to minimum alone. What do we also have to do? Maximum to minimum divided by 2. Very good. So that's 2 amplitudes right there. Okay, that is 2 amplitudes. How high is this? 1. How low is this? -2. So what's our answer going to be again? 1.5. 3 over 2, which is 1.5. You can write it either way. And the midline, let's just go ahead and throw that in there. Why not? It's not that much extra work. Tell me when to stop the line for the midline.
Further.
That would be the midline. Very good.
Negative.
And I hear negative 0.5. Technically, you would not get that credit for that in the AP exam. What do you need also? Y equals negative 0.5. You always have to label your variable. In this case, it's a y. You're cutting through the y-axis. That would be your midline. Okay, and finally now, what do you think on this one? It actually is. It's a very tricky one. This is periodic. This is periodic. So tell me, what is the true maximum? Is it this point right here? No, that's a local max. What's the absolute max, though? Okay, and is there another absolute max? Right here. That would be one cycle. From there to there. That's one cycle. And so this is periodic once again. This is periodic. And so how far apart are those units? What's our period here? From 0 to 10, I agree. 0 to 10 is 10 units. And the amplitude. This maximum all the way down to this minimum. That's 4 units up. How many units would this be? -2. So how far apart are those? 6. So if 2 amplitudes equals 6, what does 1 amplitude equal? 3. The amplitude is 3. Very good. And the midline, where would the midline be located? Y equals what value? Very good. Y equals 1. Right there. That should be y equals 1 is the midline. Something's going on with my board. It's having difficulties trying to switch over to writing, so I might not be able to write it. There we go. I'll use my mouse. That's the midline at y equals 1. All right, with that, you have one to try. If I'm not messing up here. Uh-oh. There you go. Number 4. Go try number 4. Okay, example 2. On example 2, it says sound waves are produced by periodic changes in air pressure. Sketch the graph of a sound wave with a period of 3 units and an amplitude of 2. Now, this is the first time you've been introduced to the word wave, and that's what we're really going to see for the majority of Unit 3 are waves. Now, a wave just like this. A lot of the periodic ones we saw earlier, some of them were waves, some of them were straight lines. A wave is going to wave. It's not going to be straight lines. It's going to be curves. Okay, so we're going to do that. Now, it says first, the period is 3 units. What does it mean to have a period of 3 units?
3 units.
Is that 3 units up and down or 3 units left and right? Left and right. So to complete a whole wave, if I start from here, I need to go to 3 units to complete the one wave. Does that make sense? This will be one cycle. Everybody follow that thinking? Now it says it has an amplitude of 2. What does that mean? That's half of maximum to minimum. So maximum to minimum is actually going to be how many units? Okay, so I'm going to put that here. Max to minimum is actually going to equal 4 units. So to start, let's just say we were going to start at this highest point here. That means to return to have the full cycle be 3 units, we need to go right 3 and put a dot. Make sense so far? I always do maximum to maximum. I think it's the easiest to start maximum to maximum. Do you have the period points on there now? Now let's do the minimum point. The minimum point should occur in the middle of the 2 maximums. So what x value is the middle of those 2 maximums? 1.5. Now how low should our maximum be? -2, 4 units down. So 1, 2, 3, 4. It should be right there. Does that make sense? Now we can repeat the process. We will have another maximum after 3 units. So from 3, I would jump over to 6. And I would have another maximum at 9. Everybody following what I'm doing? I'm putting in maximums. And the same would be true for minimums. Every 3 units, you should have another minimum. So if you go 3 units, 1, 2, 3, minimum. 1, 2, 3, minimum. Does everybody have their maximums and minimums? Now it looks like if I go left, 1 from the first point on the first minimum, 1, 2, 3, I can fit that one on there as well. So might as well put that on there. Now all we have to do is connect it with a wave. So those are my maximums and minimums. So now, as best I can, I'm just going to draw a wave. So a wave will kind of go like this. And there's our sound wave. All right, I have some questions for you. What's the midline? 0. 0 would not give you credit on a test. I'd say you know what you're talking about, but it wouldn't give you credit. What do you need to say to get credit? Right, y equals 0. This would represent the midline right there. That would be y equals 0, the midline. That right there would be the midline. And again, my board is out, so I'm having to write with my mouse. Sorry about that, but it is what it is. There's your midline, y equals 0. With that, I believe we have another one to try. I want you to go try number 3 in the back of the packet now. UL number 3. All right, example 3, part 1. It says, consider how the pedals on a bicycle rotate as a bike is being ridden. Ridden, rode, that, would you say ridden? The bike is being, my kids would say righted. The height of a bicycle pedal varies periodically as a function of time. The maximum height is 18 inches and the minimum is 6 inches. Complete the table here. And so they gave us some options to look at. Remember, a period is maximum to maximum. And so this is going to start at 18, which is its maximum. It goes 15, 12, 9. How much is it changing by each quarter of a second? 3. And so it gets down to 6, and now it hits 9. So what does it mean? What value would come after 9 here? 12. This would be 12, 15, and 18. And at this stage, we can identify the period. Did they actually tell us the period? Okay, no, it's right here. Identify the period. Well, how long does it take to go from maximum to maximum? Maximum to maximum. How long did it take? 2 seconds. Therefore, the period is 2 seconds. The period is 2 seconds. Okay. Identify the amplitude. Do you remember how to find the amplitude? Maximum to the minimum divided by 2. Okay. So the maximum is 18. What's the minimum? So how many units apart are those? 12. So here's your formula. If you want this, it's the amplitude is going to be the maximum minus the minimum divided by 2. By the way, the formula for your midline is maximum plus minimum divided by 2. So the amplitude is maximum minus minimum divided by 2, which in this case, we're talking as 18 minus 6, which is 12, you already told me, divided by 2. What will we get? 6. And so this will be 6, and the unit here is inches. 6 inches. That's our answer this time. Okay, so now it says graph the function for the first 5 seconds. So I typically, if we ever get to pick, this one we don't get to pick, it tells us the x value and the y value. Time is the x, that says t there. H would be the y. We go 0, 18. And then 0.25, 12. 0.5 at 9. 0.5 at 9 is going to be right there. Did I mess up? I did. Darn it. This next one, this 0.25 is not 12, it's actually 15. This is 12. There we go. Now I'm back on. Okay, and then 0.75 is 9. 0.75 is 9. 1.0 is 6. And now we repeat the process. 9. Now, where this is not accurate, this data is truthfully, this should not look like a V. It should look like a wave. We'll learn that in the coming days, but since this is what the data says, we're just going to graph it as if it is accurate. It's just not. So I'm putting on all these dots, and we'll connect them with the straight edge in a moment. Truthfully, this should be a wave, though. Real world periodic functions are almost always a wave. So at 4 seconds, we should have completed our second. Yeah, just want to make sure I'm accurate there, and that'll be the last point. There we go. And that's part 1. Okay, how about part 2 here? A periodic function goes through 5 complete cycles in 4 minutes. What is the period of the function in seconds? So if you remember, 1 cycle is equal to 1 period. Okay, let's go ahead and write this down so we can keep track of our math. What did I say 1 cycle is equal to? 1 cycle is equal to 1 period. Which means if 5 complete cycles is 4 minutes, then 5, what's the same thing as a cycle? 5 periods. 5 periods then therefore equals 4 minutes. Are y'all following what I'm doing so far? They said cycle. Do I have to use the word cycle? No, a cycle is the same thing as a period. So I substituted. So we have 5 periods equals 4 minutes. We want to know what's the value of the period. How do we get the period? Well, algebra. What's the 5 doing to the period? Is it adding, subtracting, multiplying, dividing? What technically would they be doing to each other? Multiplying. What's the opposite of multiplication? Division. If I divide by 5, you're just freezing on me. If we divide by 5, we should get what 1 period equals. There it goes. If I divide by 5, we should find out what 1 period equals. What does 1 period equal? 4/5 minutes, which is the same thing. Does anybody know what that is as a decimal? 0.8. So you could write it either way, as a decimal or as a fraction. There you go. Any questions on how I calculated that? How did I change from 5 complete cycles to 5 periods? One cycle is 1 period. Okay. The period of a function is 8 seconds. So what are they telling me? If the period of a periodic function is 8 seconds, how many cycles? So what's another synonym for cycles? Okay. So if cycle is the same thing as period, I can exchange this with the word cycle. 1 cycle equals 8 seconds. So how many does it go through in 30 seconds? What math do you think we could do to figure that out? Would I be multiplying 30 times 8? You'd be dividing. It's going to be 30 seconds divided by 8 seconds. It's going to tell us how many cycles. 30 seconds divided by 8 seconds. Now, 8 does not go into 30. But what number goes into both 30 and 8? 2. You could say this is 15/4 cycles, which is the same thing. Okay, think of quarters. Dividing by 4 is like quarters. 15 quarters would be how many dollars in cents? If you had 15 quarters, that would be 3, not 25, 375. That's 3.75 cycles. That's our answer this time. Dividing by 4, I think it's a lot easier if you just consider money, because most of us know our money better than we do our other fractions. Okay, and finally, the amplitude of a periodic function is 2.5, and its minimum value is 0. What is the maximum, the function's maximum? Okay, do you remember what's the formula for amplitude? If the amplitude is equal to maximum, what did I say? Or what did you say I should say? Yeah, that's right. It's maximum minus minimum divided by 2. They gave us some values to substitute in. What did they give us that we could substitute in?
The minimum.
The minimum, which is, they said 0. They said that is 0. What else did they give us? And the amplitude is 2.5. So how would I solve that? What's the opposite of dividing by 2? If you multiply both sides by 2, what is 2 times 2.5? 5 equals, those would cancel out. 5 would equal, what's maximum minus 0? Just the maximum. 5 is equal to the max. So now you've seen some formulas as well. And with that, I'm going to have you try number 2 on the back of the pack. Third DOL for you to try, number 2. All right, now let's take a look at example 4, part 1. It says, consider the periodic function shown. What is the period k of the function? So this time they're giving us that letter earlier I gave you that k refers to typically the value that it takes to repeat. What is the value of k on this one? How far apart is it from -2 to +2? How many units is it? Or you could go from this maximum to this maximum, doesn't matter. From 2 to 6. How many units is that? 4. So the period is going to be 4. And it does not say any units, so I'm just going to say it's 4 units. The period is 4 units. From maximum to maximum, it's 4. Or you could look minimum to minimum, it's also 4. So it says complete the function behavior on the grid. So every 4 seconds, we should have another maximum. 1, 2, 3, 4. I'll put that. 1, 2, 3. Run out of space. I won't have another maximum. 1, 2, 3, 4. This would actually be a maximum over there. Now for the minimums, 1, 2, 3, 4. 1, 2, 3, 4. If you connect your dots with lines, we should have our function here. Two units. Try to draw mine. I need another line that goes 2 units over, and now I'll move it. Make sure it's parallel. Whoops, wrong one. I want to move that one with the arrow. Move that one back. Okay. So there's part B. You should have something similar to that. Now it says show that. This is that formula I gave you earlier, the definition of periodic right here. Now, what makes this periodic again? What does the F's represent? The Y's. It has the same Y's with different X values. Does that make sense? Okay, what we just found out is that K is 4. Let me go ahead and put up here, this equals K. I want no one confused on that. The period is 4. That is your K value. So K is 4. What is K? 4. Okay, so now let's just pick an X value, and let's just pick the X value of, oh wait, it tells you n equals 1 and n equals, oh, that's n. Let's pick the X value of -2. All right, I'm just picking it at random. What X value did I pick? -2. And you'll understand why I'm doing this in a second. For X of -2. If X equals -2, let's begin with the easiest part. If X was -2, what would F of -2 mean? That means what's the Y value when X is -2? So look on the graph. Where is X -2? Right there. What's the Y value when we have an X of -2? +3. Does that, you follow so far what I've done? I just evaluated the function at -2 and we got 3. Okay, now what we're going to do is we're going to plug in when n is 1. I'm now going to use this side of the equation. So now, I've found F of -2. I actually found this left side. I did this first. I did this part first. Now what I'm going to do is I'm going to take the left side of the equation. I think it said left. I meant the right side of the equation. I just did that. Now I'm going to find the right side of the equation. We already know K is 4. We've solved that already. And I'm going to do that right here. So we have F of, and it says X. What are we pretending X is to begin? -2. Plus, they give us an n value. What n value are they giving us first? We're going to use 1 times, what's K? 4. Now let's do a little math. 1 times 4 is 4. So what's -2 plus 4? So that would be equal to F of 2. You see the math there? -2 plus 4 is 2. So let's go evaluate the function at 2. Here's where X is 2. What's the Y value when X is 2? 3. This is periodic. Now, how do I know it's periodic? What can you tell me about my Y values? Because my Y values are the same, this is periodic. Since those are the same, this is periodic. The Y values are repeating every 4 units. Now, what that n means, if you're like, wait, what does that n mean? That means they were going to be 1 maximum apart. You follow? So when I plug in a 2, what will that mean? It's going to be 2 maximums apart. I meant to click orange. Let me try this again. Now we're going to do the same thing, but with an n value of 2. So now I'm going to do this with an n value of 2. So we're going to say F of, what was our original X? -2 plus, what are we now saying n is? 2 times, what was K? 4. and we're going to evaluate this. What is 2 times 4? 8. So really what we're doing, we're evaluating f of negative 2 plus 8. What is negative 2 plus 8? 6. We're evaluating f of 6. Find 6 on your x-axis. It's right here. What can you tell me about the y value there? Not negative 3, but it's positive 3 as well. Would this be periodic? You bet. It's periodic because all 3 of these are producing the same value of 3. Does that make sense? Now, what's the difference between these? I started at what x value? Negative 2. So when I plugged in an n of 2, it did not give me the first period. It gave me the second period. Are you all following that? What if I plugged in n equals 3? What would we end up with? The third period, or the third maximum, you could say. That makes sense? What if I plugged in an n of 10? You would get the 10th maximum. Okay, that's what the n is. So let's translate this formula from the very beginning all over again. This is saying a periodic function should have the same what value? The y value. Will the x values be the same? No, but they will be the same amount of units apart every time. Which letter deals with how many units apart it is? The k. The k tells you how many units apart. The n tells you how far down, like how many maximums later or how many minimums later you want. If it's positive, how many before if it's negative. Yeah, before. Remember, scan that field. Try it. Okay. This was part 1, so let's go to part 2 now. It says in Austin, Texas, the average high temperature for each month is shown in the table. All of this. It says first, sketch a graph of the function representing the scenario in the table. So let's go ahead and do that. So we're starting here. January is month 1. If you're not familiar, we're in January right now. That's going to be month 1. And we have 63 degrees. So find 60 and guess where 63 would be. I'm going to just say it's about right there. Put that dot. February is 2, so we'll go to 67. March, 75. And make sure you're on either global Wi-Fi or DIC global or DIC Wi-Fi when you try this. 81. Okay, hopefully you're getting pretty close. You might be ahead of me. It's not working for you? Okay, just take the other pass then. Again, 1264. Okay, there you go. Now, once you plot your points, you can try to make your wave best you can, connecting those. Okay, so question for you. Let's see if you got your thinking cap on. It says, describe the period of the function. What do you think the period is? How about 12 months? Why would it be 12 months? Because it's a year. Yeah, you bet. If you get looking at your picture and get confused, and especially since I missed some of the dots, you get confused. But the easiest way is this going to be 12 months or 1 year. That's going to be our period. So when you come down here, describe the period of the function. The period is equal to either 12 months. I will do that since that is, you could say 1 year. But since our x unit's counting by months, down here, that's how we did this. I'll just say it's 12 months. Okay, find the amplitude. How do we find the amplitude again?
Max minus minimum divided by 2.
Okay, maximum minus minimum divided by 2. What's our maximum? That's our max. What was our minimum? 63 was our minimum. So we'll take 100 minus 63, and then we will divide that by 2. What is 100 minus 63? 37. So it's 37 degrees divided by 2, which is 18.5. Very good. Now the midline would be 18.5 degrees below the maximum or above the minimum. Both are true statements, so you could go either way. And that's why, if you remember me saying, the midline formula is so similar, but it's just going to be maximum plus minimum divided by 2. That's how, if you ever need to find your midline, you do maximum plus minimum divided by 2, and you'll get that number that's 18.5 less than 100, which I would getting 81.5. It seems like 81.5 might be the midline right there, but that's how you would do that. Okay. With that, try number 6 in the back of your packet. Number 6. Example 5. So now we're just going to go some characteristics here. So let's go through and identify some things. Tell me about the period. Can we identify the period on this? Yeah, it'd be this point here. Sorry, get that board's not working. This point here, absolute max to an absolute max. This would represent one period. How many units apart are those? 8 units. I agree. The period is equal to 8 units. They didn't describe anything else, so I'll just say 8 units. That's 8 units. Okay. Now, how about the amplitude? How do you find the amplitude again?
Maximum minus minimum divided by 2.
Maximum minus minimum divided by 2. So this right here would be 2 amplitudes right there. That is 2, I'm just going to say amplitudes. What is the maximum here? 3 minus, what's the minimum? -3 divided by 2. What happens with back-to-back negatives? They actually add. So 3 plus 3 is 6 divided by 2. It's again 3 units. Okay, the maximum and the minimum. We'll just identify one. Where does a maximum occur? What exact point? Let's do it as a coordinate point. What's the maximum? When x is -6, the y value is 3. That would be a maximum. Where's the minimum? -2, -3. Okay, good. Intervals where it's concave up. Now, there's more, by the way. There are more maximums. I just listed one there. Intervals where it's concave up. What does it mean to be concave up? What does it mean to be concave up? What does that mean? Review. It means it's curving upward, or its average rate of change is starting to increase. Here's how it works with periodic functions. Now catch this. If you find your midline, concave up is going to be on a periodic function. Concave up will be below the midline. So here's my midline. You see my midline? This right here is concave down because it's curving which way? Down. But when it's below the midline, it's starting to curve up. So you're looking at the intervals below the midline. So the intervals here, I'm going to use this one, would be from, actually with intervals, with concavity, you use parentheses, not brackets. So it would be from -4 to 0. And I'm going to put -4 plus nk, and we'll write down what those mean in a second, to 0 plus nk. Technically, you don't have to put, what is 0 plus nk? I should do it on these as well. The max. I'll come back and I'll sneak those in. What is 0 plus nk? What's 0 plus anything?
0.
Not 0, but
Anything.
so whatever the anything is. So you don't actually have to have this 0 here. This would actually get canceled out there. You could remove that. But where we need to write is k is the period. What's our period here? Where k is equal to 8. And n can be any integer. So the value is going to be a z. NEZ. That means if it was 1, that would be 1 period over 2 and so forth. So on these, I'm going to come back here and I'm going to sneak that in. I'm going to rewrite these. I'm going to put -6 plus nk, 3 plus nk. I'm going to go ahead and write that in because I think that's just better to do it that way. So the maximum here, let me try this again. The max would be -6 plus nk. And then negative. Oh, wait, the y's are always positive 3. I don't know how to do the. Sorry. It's just the x values, but the y value would always be 3 on the maximum. So we can go ahead and put a 3 there. That will always be the maximum, a value of 3. But it's -6 nk, and again, where nk, this is true about k's. And over here, I need to sneak that in on the -2. It's going to be -2 nk for the minimum. So the minimum is going to be -2 plus nk. There we go. Now that'll find all of them. Okay, so where are the intervals where it's concave down? We pick any one of the values where it's above the midline. So here I would say from, where does this one start? 0 plus nk. Again, you don't actually have to have 0 plus nk, but 2. How long is it still concave down? To 4 plus nk. And again, the 0 would get canceled out there. Points of inflection would be the midlines. Those would be the points of inflection. So give me one point of inflection. How about this one right there? What's the coordinates for that point of inflection? 0, 0. The points of inflection are always zeros. That's where we're changing concavities. They're always zeros, so the y value will always be 0. So it's 0 plus nk. That part repeats, but the y value stays the same. The y value will never change. And so this here, the 0 could cancel out. You don't have to have that. All right, we could try this again. Let me look real quick. Or wait, do I have like this? Okay. Let's try this one more time. Let's see if you can kind of call it out to me. How well can you rock it through this? I'm going to do a countdown. I want you first to establish how many units is the period. How many units? This is going to be our k value. How many units is our k value here? 5, 4, 3, 2, 1.
4.
It's not 4.
8.
It's 8. Yeah, you don't divide the period by 2. So from here to here, it's 8 units, or from this maximum to this maximum, it is 8 units. So the period is 8 units. Okay, how about the amplitude? What would you put for your maximum? What would you put for your minimum?
-3.
Divided by 2. Okay, what are you getting there? 3.5? 7 over 2, or 3.5 units. Good. Okay, maximum and minimum. Okay, this time I want to do it better this time. We already stated what k is. What's the first x value that a maximum occurs? -5 plus nk. And we'll state what n is in a moment. Now, what's the y value at every single maximum? 4. I don't have to do NK on the Y value because the Y value is always 4. That does not change. Okay, so there's my maximum. Now, what about the minimum? Where's the first minimum you see that occurs? Right there, an X value of -2. So the X value will be periodic, so you need to put NK there. But the Y value will always be the same. What will the Y value always be? -3. That will never change, so you don't change the Y value. You only change the X value from -2, whatever. And I'm going to go ahead, since I haven't said anything about N on this slide, I'll put where N is. N is an integer. Intervals of concave up. How can you help yourself know where it's concave? This one's tricky. Actually, there's two things on this minimum. Are the minimums every 8 units apart? No, it's actually this one. How far apart are those? 4. What is K? 8. This one's a little bit trickier. This one is, let me go back to this. The minimum is going to be K, this NK divided by 2. That one's tricky because it happens every 4 instead of every 8. You could divide just a K by 2 or NK, doesn't matter, by 2. So just that. This one, it does not have any intervals of concave up. Why not? What does it mean to be concave up? Curving up. Is this curving? No. So there's no concave up, nor is there any concave down because there's no concavity. And because there's no concavity, guess what on points of inflection? There is none. Good. Now with that, you ought to be ready for your next DOL. Go try number 1 on the back of your packet. All right, now example 6. Let's see if we have enough time to finish this. A storm siren makes 2.5 rotations per minute. Rotation is a cycle. A rotation is a full cycle. So it takes 2.5 cycles per minute, and the sound waves have a radius of 1 mile. Mr. Tyler's house is located 1 mile south of the siren. The distance of the sound wave from his house varies periodically as a function of time. What is the period of the function in seconds? Okay, so let's start here. A cycle is the same thing as what? A period. So if we have 2.5 rotations per minute, then we have 2.5 cycles per minute, which means we have 2.5 periods per minute. So we want to know the answer in seconds. So if you have 2.5 periods in 1 minute, 2.5 periods equals 1 minute. Well, how many seconds is in 1 minute? 60. So it's 2.5 periods and 60 seconds. Do you understand how I made that jump? Because a rotation is a cycle, and a cycle is a period, and 1 minute is the same thing as 60 seconds. How do you get your answer here? You divide by 2.5. Now, I don't have a calculator. I'm hearing 24 though. So the period, or the K value we'll call it, is 8 seconds. Where did I get 8 from? What did you say the answer was? 24 seconds. Okay, great. Let x-axis represent time in seconds from 0 to 60. Let the y-axis represent the distance from the sound wave is from Mr. Tyler's house. The siren begins its rotation facing north. So the radius is 1 mile. He's south. It starts north. Okay, so here's how far away. If he's 1 mile away, south of it, he's 1 mile south, but the siren's 1 mile north, it starts at 2. You following that? How long does it take to get back to 2? 24, 48. Now the minimums would be right in the middle of those values. So the minimums would in this case be at 12, 36, and 60. If you connect those, you have your graph. Okay, one last little thing on this one is kind of why I put the points where I did. The midline here, it says that Mr. Tyler's house is 1 mile south from the siren and the radius is 1 mile. So if Tyler's house is 0 distance from Tyler's house, that means the siren itself is located 1 mile away. And so the midline represents where the siren is actually located. So this would be the location, the siren's distance from Tyler's house. Just to make sure everybody's following along, that would be the siren's distance from Tyler's house. So Tyler's house is here at 0. The siren is located here. The sound waves have a distance of 1 mile. And so this would be the point where the sound wave is furthest away from the house. This would be when the siren is pointing at the house. The sound wave would be arriving at the house like that. So that's the idea. The siren is aligned on the midline. That would be the maximum distance. That's when it's at Tyler's house. Okay? So now let's look at our last one here, part 2 of example 6. It says a Ferris wheel at the Orlando Eye attraction is 120 meters in diameter. The height in the meters of a compartment H is a function of time in minutes. It takes about 30 minutes to make one complete revolution. A revolution here is a cycle, which would also be known as a period. So let the height of the car where you enter the ride represent a height of 0. So we enter, when we first ride this Ferris wheel, we enter at a height of 0. This is where we enter right there. Now, it has a height of 120 meters and it takes 30 minutes. So 30 minutes, we're back at 0, which means halfway between 0 and 30, which is 15, we reach the maximum height of 120. Okay, so we could make it like a line, but truthfully, things that are rounded, like a Ferris wheel, or like I was saying earlier on the bicycle problem, should ultimately be a wave. It ultimately should come up as a wave and come back down as a wave, something like that. We don't know exactly how to look, but that's ultimately what should happen. It should be like a wave, like that. And so now that I've actually done part B, which is sketch the graph, find the amplitude. Again, our formula for amplitude is going to be maximum minus the minimum divided by 2, which in this case, it's going to be 120 is our maximum minus the minimum of 0 divided by 2. Well, 120 divided by 2 is 60. And this one's not in units. They tell us, I think it's meters. Let me just scroll right back up. Yep, meters. 60 meters is the amplitude. Okay, we've already graphed, so we've actually already done part B. All right. So C, at what time does the Ferris wheel reach the maximum? The answer is 15 minutes. 15 minutes, and we got that because in this particular case, you would enter at time 0. You enter at time 0, and that's the bottom height of 0. You don't enter a Ferris wheel at the top, you enter at the bottom. And so it's halfway between 0 and 30. That's where we got that maximum. Okay. Now with that, I believe that's it. Let me double check here. You need to go to DOL number 5. And that is in fact it. So make sure you go online and submit your answers. This is lesson 3.1. Make sure you submit that, and that doesn't need to be there. There you go. Take care.